my house. I wait for this to be finished so I can put back my antenna on and continue some H1 observation. So far, the last I had 256,000 samples so far, which is not bad, but I will continue.
Magnificent. You were collecting so much information, so much data. It looked great. Good luck. We're starting again. I'm trying to think how many times I've started again.
I have a question for you, because on your example you show that in your observatory you follow the galactic plan. So I did try to put my antenna on a equatorial mount. I have a Skywatcher HQ5. So I was successful to put it in place, but then I have hard time to understand how to, the go-to, where I need to point to get the full galactic plan. So maybe you have a clue, so I can calculate what point I need to figure out, to point the antenna in and go through the galactic plane.
Well, I have two parts of that, two parts for an answer there. Maybe not fully complete yet. I have posted a new program called Easy Dec, standing for declination. So it's up there with the Esra group. Occasionally I update all that Esra code, and it keeps bumping along. Almost daily I keep changing it, and hopefully to the better. But that new program will convert between different coordinate measuring systems. So azimuth and elevation versus right ascension and declination versus galactic latitude and galactic longitude.
That's good.
So there's now a way to convert between it. Not that I've written up anything or put up video, but there's a help screen, and you got my email, so let's figure out what the major questions are. So that's a new program to at least convert. And in the journal I put out, probably the last journal, was an article that if you have a declination, which is independent of anything where our antennas are on the Earth, a declination on the sky, what galactic longitude does it hit on the left and the right side of that standard big U picture? So that if I wanted a certain galactic longitude for further studies about the galaxy and the arms, what declination should I set it to? And then you got to figure it out with maybe Easy Dec to figure out for your location all that math. So there's a bunch of math coming all with those coordinate systems. I'm hoping that helps a little bit. And I'm trying to put more into the programs so they spit the stuff out for our convenience. I'm doing a new telescope up at Estes Park, and so I'm going through all this process again, trying to come up with even better ways. For example, if I point the antenna to someplace in the sky and just lock it down and let the Earth rotate, what declinations is it recording? And then maybe what's the spacing between all my declinations to find out where the big hole is that I should go back and fill again. So things like that are slowly coming along. If you're brave, we can talk about experimental code. Talk to me by email.
Okay.
But eventually it's coming.
Thank you.
Okay. Thank you very much.
The big dish behind me, the one that has the red stick next to my ear there, I had the opportunity to use motors to go anywhere I wanted to. And with the MIT SRT program. It's kind of old, that ran on Linux quite nicely. It knew how to control my kind of motors. So that was a match set. It's written in C, so if you have a way to talk to your mount, you could change the code and do things. So eventually we'll get to something like that. But that's what I had in place, and that way I could actually just go to a galactic place for 15 minutes, and then the program would actually say, okay, that's long enough, let's go to this new place for 15 minutes. And so that allowed me to get the 3D space of galactic hydrogen density. That made it a whole lot easier. But then, of course, I had to convert that data format into my Ezra data format. But by then I had a way to do that. I have great dreams of wrapping another program around EasyCall for collect. Something like Easy Command, where you tell it, I want to go to this place in the sky and sit there for 15 minutes taking data, and then I want to go over here and do this. And maybe there's just a great big box where you put in the way to control your motors. And I'll have a couple examples, and we'll keep building up the database. But that would be cool. Rich is trying to do this with essentially an electronic mount, where instead of motors, he's playing with the phase between antennas in an array. But that's just like motors as far as I'm concerned. And so his may be the first example of how to control something outside of EasyCall to change the pointing of the antenna. These are big dreams. They all take a lot of time.
Very good, very interesting. Very interesting.
But that's kind of the framework.
So what I understand is that when you get to a longitude in the galactic plane, you say you need to measure 15 minutes per line. Huh? That's what you say.
That's what I chose to do. I don't know if it's a good number or not. It worked.
Okay.
Is it too much? Is it too little? I don't know. It takes forever. If you do it a cross section at a certain galactic longitude, so you're looking above and below the galactic plane, 15 minutes times 10 for above and times 10 for below, so it's a 6-hour measurement for one galactic longitude. And so it takes forever, but I'm watching videos and reading books, so okay.
Yeah, but on the other side, what I am doing is that it takes 24 hours to do all around.
Well, that's true, yeah. With drift scan,
you are gaining.
it works. So, there's a new thing in Ezra also. If you're interested in just a certain place, maybe a galaxy or something like that, you find the declination and then you do drift scans. But Ezra has EasyCall, I guess, has a way to filter out the interesting part. For example, the galactic crossings. Okay, maybe above or below the galactic crossings. Yeah, okay. And I put a new one in for right ascension and declination that you could put a square of a window. If your samples fall inside that window, then collect those radio spectra as interesting and put them off in a separate file, just like I was doing for galactic plane and stuff. So that's another option that's already in place and posted. So many choices on Ezra, I must say.
I have to test.
All right, that's enough for an Ezra for a little while. Andy, who's next?
I'd like to just ask you a question there about Ezra, if you don't mind, Ted.
Yes, okay.
How far have you got with getting SDR Play to work with it?
I have no hair, as you can see. It's getting less. My experiments, in every way, show that SDR Play, at least the one that I have, is deaf at 1420 megahertz. I can see 100 megahertz in the FM radio stations just fine. I think I could probably go down lower into the ham bands, although, you know, the antenna I got connected is probably pretty poor for that frequency range. But I've used, I think, both of their programs from SDR Play. One's called SDR Connect, and one's called SDR Uno. And when I look at what it provides at 1420, I never see any kind of bump out of hydrogen. But I do when I use a simple RTL SDR from Noelec plugged in with my software. And my software isn't fancy inside. So what's going on? Is it just the hardware that can't see it? Are there certain filters or adjustments inside the SDR Play that I just haven't found the knobs for?
Which SDR
but
Play?
There's another guy in the Facebook group who's using it. Is it just because he's got lots and lots of amplifiers on it and low noise floor, or what?
I mean, I've got, I don't know about the 1420 megahertz, but I have the RSP Duo, which I was going to try and use for interferometry. And we can come back to a second. It would also be an option potentially for the dual monopole setups, which we can talk about in a while. But I haven't tested it yet specifically on the 1420. But my issue at the moment is SDR Connect and SDR Uno. I can't see any way that you can actually record data off it in the sort of processable way that you can get off Ezra or even off SDR Sharp. And so apparently in the past SDR Sharp used to work with SDR Play but doesn't anymore.
We have this great big dish down in southeast Colorado called DSES, Deep Space Exploration Society. And they've been able to record using their SDR Play down there. But they got a 60-foot dish, so maybe there's the gain. Loud signal, a loud signal over the noise, where that doesn't happen in my backyard. And he was able to record a wave file, but only a spectrum that's appropriate to audio frequencies, as if like for ham radio. The problem is the file is huge. It's recording all the IMQ and everything and writing it into a file as fast as it can. Maybe it's dropping samples. I don't think we care. But it's such a small bandwidth, and we need more for hydrogen. So that was an inadequate solution. And I haven't figured out quite what the database, what the data format is on that thing either. So I have no conversion to Ezra yet either. So we were disappointed at that. I agree with you, that's the only recording that I found, and it seems inadequate at the moment, just in beta.
I have used both SDR Duo and SDR Play, but with GNU Radio, with the West Virginia University Radio Astronomy Laboratory programs, and they record spectrums every 10, 30 seconds, whatever time interval you put. And I used the Duo with interferometry using two 750mm feed horns, but on the sun, so lots of signal there. But when I get a chance, I will look at it with EZRA.
Now, with the program, which program did you use? The Despera from West Virginia?
Yeah, that's right.
West Virginia University. Yeah.
Yep.
Okay, and I keep trying to get back to that, and I'm having a terrible time just trying to get Ubuntu loaded and GNU Radio to work with it and all kinds of stuff. That's what I've been working on for months. I keep running into more system complications.
Oh, I've now got an Ubuntu. It's 2204 with EZRA and GNU Radio on it. So, and they're all working.
I've seen that before. Now I have to get back to it. Yeah.
Right.
And my latest plan was to go with what I had working at one time with Despera and put my little new module in there that writes out not in comma-separated variables as they want, but in the Ezra format, which I've done elsewhere. I just need to get all these parts in one place and kind of write up how you get it. Now they have on Despera a nice image of a disk system to make a bootable drive, and it fails for it. It tries to look at something else inside the USB and then tries to go off to the CD-ROM or the DVD, whatever it is, some disk reader, that of course is not involved. So I got a programming error inside the file that they provide me that's supposed to do it magically. What was your method to get Despera into Ubuntu 22?
I used the image that I got EasyRA working on, and then I went to GitHub, and on GitHub it gives you the instructions on how to download it and the extra things that you have to do, like editing the bash RC file, etc.
When you say
okay.
GitHub, is
I
that
was just looking
GitHub
at
to
that
Spira?
half an hour ago.
Yeah.
And then I ran into a problem that I guess I was trying to pull down Marcus's code and put it in place. But then I ran into a problem with Despera also, that something wasn't right. It's a matter of getting all the parts in the right place. It seems fragile.
Do you want me to send you an image?
Not yet, but I'm taking your picture. I'll come after you. Thank you for your help. I suppose, Andy, though, if you wanted to try to play with SDR Play, that can be done with that other program I sent you at one point called Easy Call with an S after it for SOAPy. And that is a possibility as well. I haven't tried that recently. I'm trying to push on this GNU Radio method. So there's a couple opportunities. Thank you, Andrew, though, for all those good ideas.
I will definitely have a go at both of those things. Thank you, guys. That's brilliant. I felt I was up against a brick wall and didn't know where to go. So, yeah, it's a shame because the RSP Duo seems such a wonderful piece of kit. If you can get it actually working, to have two channels which are co-clocked is a brilliant idea.
Yeah, the problem with it is that on a single channel you can have 10 megahertz bandwidth, but on dual channels it's 2.5 or 2.4. So that's the unfortunate bit with it.
Yeah.
For hydrogen.
There's a nice thing about it is that it does have the input and output for the clock. So actually, if you really wanted to go to the full 10 megahertz bandwidth, you can get a second device, and you can clock both of them together synchronously by using that output clock from one as the master into the input of the second one, and then you can run each one individually at the full bandwidth.
Yeah, I went ahead and bought the Nano Blade. It's very expensive. Not Nano Blade, the Nuand Blade, and that you can have really wide bandwidths, and that works reasonably well. But sort of, it's not my preferred choice. I prefer AirSpy at the moment.
Andrew, let's talk about bandwidth a little bit. For hydrogen, how much bandwidth would you prefer?
If you increase the bandwidth, you increase the sensitivity of it. You get a bit better signal to noise.
Yeah, I'm thinking. And better resolution for the frequency information.
Yeah.
My policy was eventually on GNU Radio to use 10 megahertz bandwidth to make the readings, collect all the FFT, frequency spectrum, and then chop off the edges because I just don't need them anymore.
Yeah.
That just saves on the file size. Good ideas. Thanks for your thoughts.
Yeah, thank you, guys. There's certainly a lot to think about there. Fantastic. I'm going to come back to you in a bit, Andrew, because I know you've got a bit of a presentation on 3D printing. But while we're about it, perhaps let's just perhaps go to Heather first. Anything you'd like to talk about, Heather?
No, not really. Much more interesting to do all this good stuff at the moment. Yeah. I will offer sometime, yeah, you and I can talk about the meteor stuff, but if it's interesting to anyone else, I can just do a bit of a talk on that if you like sometime.
Yeah, I mean, we could do that. This is specifically a hydrogen line group, but I'm sure we could dedicate a bit of time to that if people wanted it without any issues, really. But if anyone else is interested in meteor observing, having a talk on it, please could you just drop me a separate message to that effect, because it's meant to be a hydrogen line group and I don't want a sort of group effect where everybody feels they have to say yes to it. So we'll just see how many people ask for it outside of the forum. But certainly I would like to talk to you about it because it would be a very, very great help to me. Thank you. Okay, well, fantastic. Thank you, Heather. So Adrian, anything you'd like to talk about?
Well, I'm running a little bit late, so I just popped in. Don't really have much to present as far as any observations or anything. I've had a lot of computer problems, and I'm still struggling to try to get some systems running so that I can use them for data collection. And or also looking at possibly including Raspberry Pis as input devices for the SDRs. And I'm kind of in the same situation. My main device that I'd like to use is the SDR Duo, and so kind of looking forward to Ted maybe making some progress on getting EasyCon to work with the Duo. So that's something to look forward to. But that's pretty much. I just thought I'd pop in and listen in.
No, it's great to have you here anyway. Thank you very much. Okay, so let's moving on to Andrew then, because so you got a little bit of presentation for us on 3D printing waveguides. I'm very much looking forward to hearing this.
Are you going to go back to Paul?
Oh, Paul. Oh, sorry, Paul. We missed you out. I do apologise. You disappeared, then you came back, and I forgot you were halfway through a presentation. Please forgive me, my friend. So you're actually muted at the moment, so we can't hear you. But you did right. Let's go back to Paul first. Thank you very much, Andrew. Thank you. So start again, because we've forgotten what you're talking about.
I've got basically a simple question. Maybe I'll have another go. I've shut down all those tabs I had. I was rather pleased that the one that came up rather randomly was Ted's video that I was listening to the other day. Anyway, so share screen.
Then I went to Windows, and you could pick which window, perhaps.
Okay.
Yeah. That was the kind of thing I was looking for.
Don't accidentally press the red button that says leave.
Okay. I don't know. How do I know I've shared this? Can you see?
Yeah, we can see it.
Oh, you can. Okay.
Scan Terrier Limited, 30, the Metro Centre, Talbot's Lane.
So oh, you've got the right. Can you see an offset satellite dish?
Yep.
Yes, with a big arrow, right.
Yeah. Okay. So I'm just at the very early stages of designing my H-Line observation system, and I was starting with a 85 centimeter dish, but then when I tracked down the manufacturer's data sheet on it, and of course it's I think it's what they call. I mean, I don't know anything about the geometry of these things. I have written to them asking for the detailed geometry, but it's an offset it's an offset disc. And really my question for you guys tonight, and there'll be loads more following in days ahead, but can I use that dish, an 85 centimetre dish, and can I just calculate you can see what I've done here, as to where the feed horn detector should sit. I was a bit confused as to whether I could even use this dish.
Yes, you can use the dish, and typically just put the feed horn where the LNA is, or LNB.
Put the feed right here.
Yeah.
Ah, okay. And the way they've drawn it here, it doesn't look. I mean, I couldn't make sense of that either, because it looks like it's pointing somewhere over here.
That's the offset.
Hold on, yeah, that is true. That is offset. But okay, that's fine. Maybe we
Yeah, it is a rubbish drawing. The feed should point to the centre of the dish, or pretty close to the centre of the dish.
This axis, this feed axis, should be pointing to this point here.
Yeah, roughly.
That point there should point to this. Yeah, okay. I mean, that was confusing me as well. Yeah, you're right. It's a rubbish drawing. I'm hoping that they would pass my mail on to their engineers so that I could to see how this thing has together. Okay, so if it can be done, I might start with this, and then see how we get on. Want to get this bit working first, and then I'm going to. It's got a motor on it, and I'm going to put an accelerometer on just so I know where I'm pointing. But that's a long way down the line. I just want to see if I can get a feed horn working with this, and then.
So your other thing to bear in mind is, if it's an offset fed dish, it probably isn't parabolic, so your picture's slightly above the screen. The dish works as a reflector, not as a not as a complete parabola. So it's only part of a parabola. So if your feed is pointing at the middle, then you will actually be looking at the reciprocal angle of that. So in that picture, it's going to be roughly vertical. Does that make sense?
No, I have to think.
Well, the pointing gets complex. Ezra says you don't have to worry about it too much. You just point it at the sky and let Ezra and the galaxy tell you what declination you've ended up at, and then you can start doing math and tilting it with better knowledge.
Yes.
So don't dwell on that too much.
Okay.
I was using a dish much like that, and with just a simple dipole, and it works. The signal isn't strong, but hooray for amplifiers.
Yeah.
But if I'm right, Paul, you were trying to calculate where to put the feed.
Well, originally I thought that this was a part of a sphere, so then I was just calculating the distance, just because I could measure the chord, and it came out at 1.4 meters. And then I had a look at the data sheet, and then realised that this wasn't a bit of a sphere at all. It was something rather strange.
Well, it's a slice. It's a slice of a parabola, is what it is.
Yes.
You're taking a slice of a parabola. So, if you were to imagine extending all the sides of that geometrically correctly, then you would wind up with a parabola. But this is taking a slice out of it, so that the feed is not impeding the signal that you're trying to measure. And I think what this diagram is showing is a design where the actual feed arm rotates out of the way. And I think what they're trying to indicate is that you have to swing it up. That's what that big arrow is showing. Swing it up, so that it locks into place where it should be at the focal point of that slice of the parabola.
Yeah.
I've just put a link in the chat.
Oh.
Of a very simple little diagram that shows the difference between a an offset fed and.
Well done. Oh, thank you. Yeah. Thanks very much, Heather. Yeah, I mean, for tonight, that's enough to keep me going. I think you can continue, Andy.
Yeah, I've actually just pulled that up, and if you just bear with me a second, just for the sake of people who are watching the show online, let's just pull that link that we've just been told about.
Yeah.
So it's worth saying that Jason Burnfield, who was the engineer at the VLA, who took part in that nano VNA workshop at UCARA, he is in the process of making himself a 3-meter offset dish. And I think he was saying to me, don't quote that, but I think he was telling me that Chime uses offset dishes. The point is that actually offset dishes are becoming more popular amongst professional radio observatories, so they're not a bad idea at all. He was, and I hesitate to say that I understand this very well at all, but I'll just give a quick summary of what he said to me from a non-understanding person. His point was just that it's part of a parabola, but you can design it like the picture at the bottom here on this KA1GT diagram. You can design it so that the feed actually comes out on a horizontal arm like that, which means that because it's therefore only half a parabola, actually means that you can use the arm to sight along to aim the dish. So if you do that, then you don't actually have an issue with trying to find out what you're pointing at, because you've got an excellent sighting arm to use for that purpose. So he's making a 3-meter one, so I've no reason to think it won't work as long as he makes it strong enough.
The other really cool thing is that the feed isn't in the middle of the image.
That's right, exactly that. Just to reiterate that, that's what he was explaining to me, that you get diffraction effects, especially along the struts holding the feed up. So, which is, I think, what you're trying to say, isn't it? So, Heather, I'm sure.
No shadow and no, exactly.
Yeah. You understand it a lot better than I do, Heather. So I'm not trying to make out I know anything more than you do, but far less than you do. But just to reiterate what he said, that's why he's doing it, I think.
Exactly. Yeah.
No, thanks, Heather.
And I'm going out on a limb here. I'm trying to remember what he said, but I think he was suggesting that you get worse diffraction effects on a radio dish than you do on an optical telescope because of the wavelength. I'm not sure if that was right or wrong, but certainly he felt it.
Probably true, except that with an offset fed you can basically ignore it completely. But there's other advantages and disadvantages, but that's the significant one, is that you don't need to have the feed in front of it. The answer, Ted, is yes. I think we're looking at a direct TV slimline picture.
Yeah, and so here is an example where it seemed to work. That tiny little feed is simply a connector with 2 wires on it of about the right length. And so that's not much of a feed, and yet I was able to see hydrogen to some degree. It's a start. It's not great. I put it at the same place where the old feed was for much higher gigahertz and stuff. So that's a simple one. This is also a simple one where you just make some kind of cone and collect the data, or collect the signal down into a can, and then Andy has done all kinds of things just with probes stuck into cans lately. And then you could have a reflectors this way as well. Over here is the amplifier. I think you see my cursor, and not quite visible is a little tiny stick coming out to about here, a wire through the corner of this thing. And so you can make really simple antennas and put your toe into the galactic hydrogen world. This is all on, maybe it says even up at the top, Ezra Hardware 1. So that's part of the Ezra package that you download. Yeah, I suppose it's up on the web as well. I hope that's helpful.
Right, thank you.
I know I try to take every opportunity to say this to anybody who will listen, and loads of people who don't want to listen because they already know it or they know better. But one lesson I have learned is, as in this diagram from Ted here, it's absolutely vitally important to put your LNA as close to the aerial as possible.
And to have the right connectors, right, Andy?
And to have the right yes, and to have the right connectors.
You had the unfortunate experience of learning that some connectors actually don't touch each other, and there are different versions of them. So you had two connectors but no center pin making contact. So you educated all of us. It was good.
I can't see why they can't. These LNAs can't use ESP to actually send their signal.
I'll let you think about
that. Okay, Paul. Any other questions you'd like to ask?
No, that's just fine. And yeah, thank you, Heather, for that. I've learned something this evening, so that's excellent. Yeah, do continue.
I have another question on that, Ted. You showed a diagram there of a corner reflector. So, does it matter if you get a bigger corner reflector? The reason I say is some discussion about some logic to the corner reflectors having maximum efficiency where the sides are 3 times the length is 3 times the wavelength. And the question I'm asking is, if you get bigger than 3 times the wavelength, does it help? And would it have to be multiplications of 3 times the wavelength or not?
Well, we made this as a STEM project because they wanted to build things. So, okay, I found things for them to build. And we tested it, and it kind of worked. There are different designs here. Some of them have kind of a parasitic probe that just sits there and changes probably the SWR of the receiving circuit. And so we didn't even do that. We just put a probe kind of in the right place according to some guy's diagram. We don't know how this thing works. And we only really pointed at the sun too, to some degree. But no, we got hydrogen. Yeah, that's true. We tested on the sun. But if the radio waves are coming in, they would bounce off at 90 degrees from this reflector, and then bounce off the 90 degrees from this reflector, and go straight back where they came from. It's just a reflector straight back to the source. So why is the probe picking up radio anyway? So I'm just puzzled how it works in the first place. Making it bigger would make it a bigger perfect reflector coming straight back. If you put a flashlight towards this, it would look bright because it's reflecting the light straight back to you. Yeah, so I don't know, Andy. I was thinking making something like this out of the sides of washing machines or dryers, some great big sheets of metal bolted together. After a while, the weather gets to this stuff, which is insulation for your house. But it worked. I would say this one is the best, but it's kind of fragile, this great big pyramidal horn. Just, you saw, even at your presentation, your conference there, you can make them out of balloons or anything, as long as it's got a metal kind of funnel collecting more energy down at the bottom and into a can where the probe is in the right place.
Does it matter how big the funnel is, or can you make it any old size?
Well, they make bigger antennas for a reason. So yeah, the bigger the funnel makes sense. The corner reflector, I'm not so sure. Because again, I don't know why it works. It seems to me that any energy coming in here will be a perfect reflection right back to where it came from.
So I think what we've concluded is that anybody watching this video is going to go out feeling more confused than when they first came in. We don't know why it works.
Us too. So there you go. Go give it a try. I found that these things work. But I also found that you put sticks in the right place, as described on a video on my website, at least on the YouTube page, that, yeah, this works too, sort of. It kind of flops around in the wind a bunch because it's a flexible pipe. But this is $20 and I got it to work. I made a whole video about it. So we're reducing your excuses, Paul.
Yeah, I'm going back to the corner. I think Peter East would be the person to ask the question, because I'm sure he will.
Yeah, he put a couple of Yagis up and he was doing things.
Yeah.
Yeah, I think it was Peter that said. Yeah, I think it was Peter that suggested to me that 3 times the wavelength was the maximal efficiency. But I don't understand.
Good to me. Sure. Okay.
Anyway, the larger it is, the more you capture energy. I guess it's like optical telescope. You get more photon in. Here you get more photon.
Very, very true for something like a funnel like this. Specifically for something at right angles, I'm not sure. It could be that the bigger you make it bigger the reflectors in this case, all at right angles. Maybe then you get less noise from the ground itself, for example. I don't know. So that you're looking at a smaller field of view of the sky. I didn't really care as long as it kind of works.
According to ChatGPT,
you buy 9 or 10 used washing machine. You take the body and you make your own pen.
Well, maybe 3 at tops, I was thinking, but yeah. They make them out of wooden frames with chicken wire on them. I've seen that on the web. And that's what kind of inspired me. We could do something. There's a video about a guy that made a huge one that was kind of 6 feet on one side. It was tall as him, made out of chain link fence like in the background here. But he never finished it. He never did video number 2 telling us how it worked. He went on to other things. So beware.
If anybody would be interested in seeing a very, very large offset antenna, I'm going to try and see if I can maybe share a picture of one. And I'm not sure how you can possibly do this.
You hit share, and then you click Windows to the window that you've already prepared.
And the window is in the box that pops up when you hit share.
Well, hit share, then
and
you'll find a button for Windows.
Right.
Click on that.
Oh, okay.
Pick one that looks good.
Okay.
Oh, wow.
Is that is that coming through there?
Oh yeah. Okay. Good.
That's a very very large offset dish. And actually, if you go to the, I'm sure you've all heard of SETI, the organization SETI. They have an observatory up in Northern California that has a whole array of about 30 of these things. And they use it for multiple observations. One of them, of course, is their ongoing search for extraterrestrial signals. But anyway, this is a prime example of a particularly large offset dish. You can see how the round thing on the bottom is just kind of like a canvas cover, which actually covers the feed, which is inside of that, and they use that as just as a protector for weather. And so they've got it's a very unusual feed which is a kind of a log periodic thing that looks something like out of Star Wars. And I have a picture of it somewhere, but I can't find it right off. And so that's at the focal point of the offset dish. And they have actually cryogenically cooled low noise amplifiers and all that system being included inside that canvas covering. But anyway, I just thought you might want to see kind of a gigantic size of one of these offset dishes that we were talking about earlier.
Wow.
So this is I'm basing it up there. It's the observatory is in a northern part of California. It's called Hatton Creek, and the actual observatory itself is called the Allen Observatory because it was funded by Paul Allen, one of the co-founders of Microsoft. Put a lot of money into the observatory when it was first being built, and so they used it for all kinds of astronomical observations also, besides just their search for extraterrestrial signals. So it's a fantastic place to visit. It's just kind of beautiful country up there. But anyway, I just thought I'd be interested to share that. Let's see if I can pop back out of this now. And so just unshare. Oh boy, lost it.
I've taken over already. And so this is in that Allen array. I put a link in the chat. I visited one time. It was fun to walk around. They got a bunch of posters up on the wall to tell you what's going on. It's interesting. They haven't found it yet, but those covers are mostly for temperature. And then inside there are very fancy big glass domes that are cooled with what? Nitrogen, I guess, because that's cheaper. So liquid nitrogen to make it a constant temperature. Very fancy with many dishes. Fun stuff to visit.
Where is it, Ted?
Northern California. Have a look in the chat, the link I put in the chat.
Yeah. Okay. Sounds like a good holiday someday.
Yeah. And Heather, where are you located?
Just outside Birmingham in the UK.
That's a long drive for you. Okay.
Yeah.
Okay, well, thank you very much. That was a very interesting talk. That okay. So, shall I move on to Andrew now? Would you like to tell us about your 3D printing?
Okay, so I have a 3D printer, so I thought, oh, what about trying to print a waveguide or feed horn? So I did some searching online, and somebody's done it, gives you advice. And then on the physics forum, this is the hydrogen line antenna that I decided to use, the VE4MA feed for 1.42 gigahertz. So those are the dimensions that I'm using. And so then I decided, right, let's get on and print it. Why doesn't it advance? There we go. Right, so the center waveguide I can print as one part in my 3D printer, but unfortunately the outer thing is too large for my 3D printer, so instead I printed it in 4 pieces. They're 4 identical pieces which just slot together and then make up the feed guide with the outer baffle as well. And then I've included some attachment points so that when I try and put it on the dish, it will work. And there's also a hole in here at the appropriate place for the monopole to come in. So then, using MG Chemicals 843 AR silver coated copper spray paint. Spray painted the inside to give it metallic finish, and then insert the monopole inside it, and then we get into nano VNA. And so the first thing I did was take the unpainted plastic feed horn and just put the monopole in it and do a spectrum, and absolutely nothing at all, which is not entirely surprising. So then you put a monopole in it, so I put a 43 millimeter, and so I'm using 1/8 OD copper tube as the monopole soldered onto the SMA plug, and with the 43 millimeter we're high in terms of the wavelength, but there's a nice peak there. So then 47 millimeter, this was not what I was expecting at all, but a very broad, flat sort of region of area where you get sensitivity, and the marker is at 1.42. Similarly, if you do 48 millimeter, you get the same sort of response. But then if you go higher, you go 50 millimeter, again you get a peak, but it's a lower frequency. So I was a bit surprised that these, the area of resonance, if you like, gives you such a broad, flat region. But that's what I found. And so I think that was it, yeah. So there you are. It is possible to make a waveguide or feed horn from a 3D printer, and at the moment I've got that in my roll-off roof observatory pointing south, and I'm trying to do some measurements on it to see if the naked feed horn gives me some hydrogen signals.
I like this. This is great stuff. Now we can make metal in any shape we want. I would think that resonance got broad just because of its environment, that the shapes all around it are resonant at that frequency because you chose those dimensions for the rest of the feed, right?
Yeah.
Tell me about this magic metal paint. Is it expensive stuff? Does it just come in a spray can? What is it?
Yeah, it comes in a spray can. It is fairly expensive. I think it was £65 for a tin.
Because you're buying copper, yeah, I guess.
Copper and silver, yeah.
Okay.
The guys on the link that I put in there tried 2 different types of MG chemicals. One was, I think, nickel, and they found that wasn't anywhere as effective as the copper-silver one. But yeah, it gives a great result, easy to apply. 2 coats, that's what I've got on there. So, as I say, I'm experimenting with trying to get some signals from it at the moment.
Did you see any information on... Oh, sorry, Ted.
Is the surface smooth or bumpy or what when you're done?
So, again, the recommendations from the people that did it was to smooth down the surface. So I've actually sanded the inside to make it smoother. But it's not entirely smooth. If I go back,
I'm thinking after the paint job, I didn't realize you'd have to sand the plastic, but there are reasons why, I guess. Okay.
Yeah, so...
3D printing isn't always perfectly smooth.
Yeah.
We see it now.
Can I zoom in? Yeah, zoom down the bottom here. Zoom. Let's go at 100%. Oh, thank you very much. That's not what we want. Zoom. Let's go at 200% then. So...
Yeah, better. Good.
There are still some grooves from the 3D printer at the bottom here, but once you paint over it, it tends to fill in some of the gaps. But I sanded everything down before I painted it, because they recommend, in order to get better attachment of the paint, that you sand it, you roughen up the surface.
And after you paint it, when you run your finger across it after drying, I guess, is it kind of like scratchy, like fine sandpaper, or what? It looks a little scratchy.
Yeah, it is. Yeah.
Okay. But that's a small dimension compared to the wavelength we're talking about.
Yeah.
What type of antenna you put your feeder? What is your antenna?
I've got a 4-meter dish, so eventually this will go on a 4-meter dish.
Okay. Do you have a picture of the probe included?
No, not in this one, but it's just probe coming out the side wall.
And we're seeing the what is it called? Anyway, the shell, the outer shell, is much closer to us than that deeper end far in the back.
It's actually level, because if I go back to here, this is the
Okay.
the dimensions that's what I essentially built.
But now we can see that the probe is way behind the first surface we were looking at.
Oh yeah.
So
yeah.
yeah, it would just be a stick showing up.
Yeah.
Anything fancy to connect the ground of the SMA connector to the metal?
No, I just used when these little SMA connectors come, they come with a tab that you could solder onto. So that's on the inside, connecting to the surface, and then I just put a bit more paint over the top.
With a plastic foundation, you can solder right on top of it?
No, the SMA connector comes with a solder tab, and all I've done is include that solder tab on the inside surface, and then paint it over the top.
So the paint is covering over that tab, making contact.
Yeah.
All right, so instead of soldering, it's painting. Cool.
Yeah, I think if you tried to solder, it would just melt through your plastic sort of printed area, so you can't actually apply heat to it. But you know what might be interesting? I'm curious if now that you have a nice metallic coating on that, if you could then further increase the. Of course, it seems like, according to you, it seems to be working just fine as it is. But I was wondering if you could do some electroplating. Just immerse the whole system into an electroplating bath, and give it an additional coating of copper or even silver if you wanted to do that. Of course, it might be expensive at that, and then just add an additional layer for the paint to perhaps improve the conductivity of the whole surface.
Yeah, that's a bit beyond me.
And it works. So, ta-da.
Yeah.
So did you say you put a link for that paint?
Someplace? You posted the 3D file someplace?
No, the paint. Oh, the paint's up there. It's further up there. There it is. MG Chemicals 843 AR silver coated copper from Amazon. I got it.
MG Chemicals, okay.
And you can see how my outer bits slot together.
I just put a link to the chemical in from RS in the chat.
This is
Thank
fun.
you.
I was just wondering whether this would work reasonably equally as well if you used either aluminium or copper tape. I know that you were sanding it down to make it smooth, but given the wavelength of hydrogen and the 21 centimeters, does the smoothness make much of a difference?
Yeah, probably not.
And if when I say copper tape, I'll show you what I mean. Let me just share a screen. You can get this stuff off AliExpress for those of us that don't live in America for about £3 or £4.
Or just aluminum foil too. Yeah.
Or aluminum foil,
Now
even cheaper.
Now that you have a shape for the choke and everything else by Andrew, We just have to metalize it somehow. Yeah. That's a neat idea. I was always held back by the complexity of making the form itself. And then 3D printing may be the way to go.
Here we are.
Fantastic.
Sorry, so copper tape, double-sided, 81 pence a roll. You can get it in all sorts of sizes, or you can get aluminium tape. I don't know about silver tape. Problem is,
But Ted, if you have unlimited funds, they do make metal 3D printers.
Yeah.
Thanks.
That's
I'll
one
keep
thing
that
I
in mind.
that's one thing I considered, because there are 3D printing elements that have about 10% of metal in them. I wonder whether that would work, but it's probably not enough. But the sanding isn't in order to get the radio reception. The sanding is just to roughen up the surface in order to get the paint adherence.
Yeah, I would try with the plastic form, spray some gooey glue on it, or even rubber cement or something, just stick on some aluminum foil and see what happens. That's great.
Could
Well,
try that.
I think that the rule of thumb for surface accuracy, at least, and perhaps include roughness, is 1/10 the wavelength that you're observing at. So you can see for 21 centimeters that, you could have significantly roughened surface that would not usually affect the reflection of the 21 centimeter signal.
Yeah. Well, I will carry on doing some measurements on this and see how it works, and then if it works, I will then proceed and see about cheaper versions.
Andy has a website that you could post those files on.
well, my website, certainly, if you would like to, you're more than welcome to do so.
Can we adapt your feeder on smaller antenna?
Yeah.
I mean, if I go on a proportional dimension to reduce the size.
Well, that's the beauty of 3D printers. You can print whatever size you want.
But I guess
Yeah, but
I need to keep the same ratio of dimension.
But if you do that, that'll alter the frequency response.
Yeah.
So you have to maintain the wavelength proportion in order to have it be an effective feed for whatever frequency you're looking at. So
Yeah.
I didn't quite catch whether that 3D printed was actually printed for the 21 centimeter wavelength. I don't know, Andrew. Did you calculate for that?
It is designed for the 1420 or 1.4 gigahertz.
Yeah. So that you would have to maintain that. Of course, if you went up to higher frequencies, then you could make it smaller. But yeah, the size demands will be dependent on the frequency that you want to apply it for. It's sort of like a regular antenna. If you want to make like a dipole, you have to use the quarter wavelength rule. So you can't just arbitrarily change the size and have it be resonant at the frequency that you intend to be utilizing it for. So yeah, those dimensions would have to be adhered to.
Thank you.
That's one of the real advantages in that offset pair, because you've got an offset fed dish with a large feed like the 21 centimeter one. It doesn't get in the way. Whereas
Well, it depends on-
I don't know what the
depends on the
size
size
of
of
that
the
is.
dish. If you have a small dish, then yeah, it can just block out the whole signal. But yeah, if it's an appropriate size dish, of course the same rule applies for the size of the reflector. I believe usually you want something like at least 4 or 5 wavelengths for the size of your reflector. Anything much below that is just not really doing pretty much anything. So you have to maintain, again, several, and of course the more wavelengths sized of your reflector, the better that it functions in terms of the signal being reflected at the wavelength that you're observing. So yeah, on a small dish, you definitely want to use an offset. It's just a headache of determining, like what was being discussed earlier by Paul, determining not only where the feed goes, but what the heck are you pointing at? So it makes it really, it's not intuitive. It's not like a prime focus dish where you can have the full parabola and you kind of get the sort of intuitive sense as to where the feed would go in terms of the focal point, and that's the direction you point at. That's what you're receiving. And boy, that's just not easy at all to do with offset dishes. You have to have some other means of determining the pointing angle, as it were. So. But that's really promising, because the metal manufacturing of the choke rings, I mean, you can just do a simple antenna, and that's what that center section is. But the choke rings that really form the beam shape and really cut back on the refraction off the angles of the sides of the antenna. When you apply those choke rings, it totally diminishes all those side lobes, as it were, out of the antenna feed, and really cleans up the signal so that you don't get, for example, a lot of ground noise. If you're pointing up and you've got that antenna pointing down by itself, a lot of those side lobes really generate significant signal from ground noise. And so when you add those choke rings, it really sort of brings that whole effective area into the reflection out of the dish. So yeah, that's fantastic. That 3D printing could really simplify the manufacturing for sure. Yeah, that's fantastic, Andrew. Yeah, great work.
Yeah, thank you very much. That's marvellous. I think we're very lucky with the people taking part in this group. Certainly I learn a lot from you all every time I take part, so it's to me it's an absolute pleasure. Thank you very much for keeping coming. So there is one last thing I would like to show you. Who's sharing? Am I sharing or you sharing?
Sharing.
I think I'm sharing. I think I forgot to stop it.
Yeah, that is
I think I forgot to stop it. There we are. Okay, right. So let's. What did I want to get to? Get rid of this rubbish. Okay.
Back in time.
Right, there we are.
There we go.
So, if you can see that diagram, right, have I got a picture? I don't know where my other picture's gone. Have I got one? Let's have a look. Wait, please bear with me a second. Did I put one on my website? It's where it would be the easiest place if it's there.
So you control your website page, and we follow along.
Yeah. Can you see it moving up and down?
Yes, you can see blue stuff now.
Yeah.
You were showing us the graphs before.
Yeah, I'm just trying to find a picture for you, which I should have found before. Have I? No, that's rubbish. Anyway, okay. So perhaps just to describe it. Go back to that diagram. My deepest apologies. I should have looked this up beforehand. Or I did, but didn't think what else I might want. Okay, so right. So what I'm trying to do is see if I can improve the sensitivity of the hydrogen line radio telescopes I've got. Remember, I'm using a 150 meter solar cooker dish, which is basically a lightweight steel sheet thing composed of about six segments is composed of, and they're just screwed together. And when you buy it, it comes with mylar film on it, which reflects sunlight. So you tear that off, and then you spray it with, in my case, aluminium and zinc spray, loads of it, to try and stop it from rusting, which seems to work as long as you keep it well sprayed. And then I put my antenna, which I turn the wrong way around, and use that as a waveguide at the prime focus. So what I'm doing here is, after some discussion with Ted and Jason and other people, decided it might be worth having a go at sticking. So inside the container there's a monopole, which is, as Adrian said, they're about a quarter wavelength, which is in there slightly less than a quarter wavelength. You cut them to slightly longer than the quarter wavelength, put it inside the dish, and then you measure the output while slowly trimming tiny bits off the end of it until you get your maximum performance using your nano VNA, because it is a slightly different length within the container than it is in free space. So once you've got that about right, that's what I ended up with one of my signals. So the idea here is that those monopoles are linearly polarized, and so what I've done is I've added a second monopole at 90 orthogonal, 90 degrees to that, at the same length and the same distance from the base of the antenna, and I'm hoping to pick up more signals as a result of that, and then be able to combine the signals together, and theoretically, I'm told, might potentially improve the signal to noise ratio by about 1.4. So if it worked as well as that, it would be the same as effectively increasing the dish size by 1.4, as I understand it. I'm happy to be corrected on that, by the way, if I've misunderstood that, because I don't really understand the whole thing anyway. But anyway, there was some discussion about the best way to combine the data from the two monopoles. Originally, I was going to use a combiner splitter. I had it actually set up ready to go with a combiner splitter and a phasing cable from one to the other, but in the SARA forum, particularly Wolfgang that was mentioned from Astabelia before, he mentioned that there was an issue possibly with retransmission through the second monopole from the signal picked up through the first one, and secondly that it's going to be very difficult to predict the outcome. So what I've set it up with two completely independent systems with an LNA and an SDR on each system. So at the moment it's starting to collect data. The first thing I noticed, which is what I was going to talk about this evening, was that here I show a screenshot at the same time from the two monopoles, and you can see at the moment is just hitting the Milky Way, and you can see that the hydrogen line in the middle is just about, if I use the cursor, you can see it there just about starting on both sides as it starts to hit the side of the Milky Way. But I've got the slope there, and I noticed that the slope was in two different directions. So we had some discussion on the SARA forum about that, possible reasons for it, and there's Jorgen here gave what looked like quite a good explanation, which I'll just bring up there, which you can read for yourself. So I wondered what you guys thought about that, and whether you had anything other thoughts about the whole idea of trying to use two orthogonal monopoles to try and improve the signal through these telescopes.
I've been trying to do that for several months now, and what I've found in my experiments is that if you sample from both monopoles independently, you get less signal, and I believe that's because you're using a common ground. Whereas if you take the two monopoles and join them together with a T-piece, you get a much nicer signal. So I have decided that this isn't the way to go to improve signal noise for me.
Right. When you say you connect them together, you get a better signal. Did you have a phasing cable on one of them?
No.
Oh, just literally.
For connecting, you're just using a T connector, so
Yep.
you're truly shorting them together.
Yep.
Yeah, that's what I did too.
And what did you find, Ted, when you tried it?
I found that interaction, I don't know, 2 years ago now, I think. I was pointing them at the sun and just showing that I was getting interference. I was making a very cheap interferometer, but it's an adding interferometer because I'm just shorting the cables hot to hot and cold to cold together. That way I could power the LNAs right next to the antenna feeds. that was handy for me. That's all in a video if you really care. But was I looking at a different field of view on the sky? I'm not so sure. I guess I was looking at the sun with this interference fringe pattern. It was educational. Was it a stronger signal? I'm not convinced.
So Andrew, can you perhaps explain a little bit more exactly what you were doing?
So I have, just saying, 2 monopoles in one feed horn. So it's a similar antenna that I showed you with the 3D printer.
Yeah.
But it's made out of aluminium. And it's got 2 monopoles at 90 degrees to each other. And when I try to take each feed independently through a separate air spy or through I can use the SDR Duo or even the Blade, that I tend to get very weak signals, if at all, from them independently. If I use just one, and either one, I can get normal signals. Or if I join them together, then I can get signals. But if I try to use them both independently to a receiver, then I'm just not getting much signal out. And I just feel that perhaps that's because of the ground. You're sharing the ground, and it's not working properly.
So with 2 coaxes, you had a weaker signal. Yes.
Yeah.
No.
So sorry, where were you
one combined
combining
coax, you were getting a weaker signal. Yeah. Okay.
Where were you combining the signals when you had them running independently?
After processing. So
you had
I'm using GNU radio for this. So you take 2 air spies, 1 on each, with doesn't matter what amplifier you put in. I'll try different amplifiers. So amplifier close to the monopole, to the air spy receiver, and then I've got a 5-meter USB connection down to the computer. So 2 of them independently into the computer, and then in the GNU radio you take those independently through the FFT, and then after the FFT you can then join them together or record them independently. And in the independent traces there's very little signal if you do it that way. If you use a single air spy, either on one of the monopoles independently or with the 2 monopoles joined together, then you get the hydrogen signal.
Hey, Andrew, and we have 2 Andrews up here. So Andrew Thornett, I guess. Andrew, you use the GBT pretty regularly, along with Jason, correctly, to do observations. The greenback telescope.
Yes.
Okay. Now, if I understand correctly, what you guys have wound up doing now, the signal that you get recorded from the GBT are actually 2 independent channels. Is that not correct? There's
That's
2
right,
files,
yes.
one for the vertical and one for horizontal. And what you're actually doing is you're actually combining both of those 2 outputs from the GBT in order to improve the signal that you're observing?
Yes.
Well, that's exactly what you should be doing if you have those 2 monopoles, because that's exactly the configuration that you have on the greenback telescope. You have 2 independent receivers. They're not 2 separate monopoles combined together, but 2 complete separate receivers. And those 2 signals are the 2 channels that you see on the feed that you download from the GBT when you do an observation. And so that theoretically they're the two potential horizontal and vertical polarizations of the signal. And of course with hydrogen, the hydrogen line emission is not really polarized, so it's a fairly uniform signal regardless of which orientation that you want to try to receive from. And so what they're doing, what Jason and Andrew are doing, are just taking those 2 channels, the vertical and horizontal feed from the greenback, and then combining them together and I haven't done it, so, but I understand that that seems to improve the signal that you're observing, right? And is that correct? Am I saying that correctly? Combining those two data feeds, that you're actually improving your signal that you're measuring with the GPT, especially when you guys were doing the extra not the Milky Way, but the other galaxies that you were measuring the hydrogen line for. Is that the method you were using?
Yeah, I mean that's the idea. That is the idea.
Well, theoretically, then that's the result you should get if you do have two independent signals that are observing the same source. Then by combining those two from the same feed, but from two independent receivers, then that's the result that one should get. That the square root of 2, as you said, about 1.4 better signal, and if you just utilize the single channel from one.
Mm-hmm.
So I don't understand. It could be, again, just like Ted's having problems with GNU radio. That's such a black box, and it's mystical. So I'm not sure, Andrew, when you're combining those two signals from your attempts, whether that might be a problem there in terms of how that's being done in software.
What I was just trying to do just there was I was just trying to pull up a remote connection to one of my two monopoles, and I've been trying to do a screen video recording of the data collection. Usually one screenshot every minute, and then I could see how well the peaks were appearing, and that would possibly answer the question, because if that showed that there was quite good data coming in at the easy coal level, then it would be a question of what happens with the processing later on. That would be the issue, rather than the actual original data collection. I mean, clearly there might be some. We've got two different SDRs and two different LNAs here, and we've got two cables which won't be exactly the same length whenever we try to do them exactly the same performance. So there could well be a slight phasing issue between the two, and the clocks might vary a bit, which might create all sorts of problems. But in terms of the actual original data collection, we could at least show that it's actually picking up effective signal, rather than the two monopoles interacting with each other and causing a problem.
Well, if you were trying to listen to some kind of a coherent signal, then I can see how all of those effects that you mentioned might enter into the picture. But the hydrogen line emission is not coherent. It's essentially just more noise than you see around the surrounding area. It's basically a non-coherent signal, and so phasing and so forth shouldn't be a problem. Combining those two signals in post processing. So I can't understand why that you're getting those other results, Andrew, with your experiments.
I'm using GNU Radio, and in GNU Radio I'm saving a file every 30 seconds. And within the GNU Radio chain, I'm saving a file from each independent FFT every 30 seconds, and then I add them together, and I also multiply them together, and I save those as well. And it doesn't matter where I look in these spectra, I'm getting much less signal from when I use them independently than if I try and use one on their own or join the two together. I don't know why, but that's the results I'm getting.
It's still not clear to me. When you say you use one on its own, let me describe it. Correct me where I go wrong. You've got your feed into your LNA through various cables into a digitizer, into GNU Radio, and you see an FFT. Is that right?
Yep.
And then when you have the other system in place, ignoring everything that comes from it, you get a worse signal. Is that right?
Yeah.
So that is kind of weird. Yeah, that shouldn't be happening. What Andrew Thornett said about cable lengths will matter if it's a coherent signal. I'm not sure how coherent it would be, but cable lengths, when you're talking about 21 centimeters, you know, a factor of 10 would still give you a perfectly usable signal, so it's not going to be that. The same would apply if you've got if you just connect the two probes together. You're changing the impedance, so that shouldn't matter too much, although most of these horns are designed to run at a specific impedance to match the.
But if you combine both of those into a single LNA, for example, if both of those probes are just being put in parallel and combined into a solver, for example, theoretically you'd be looking at, say, 25 ohms, not 50. If you use the VNA and tune it properly for maximum performance, as Andrew was mentioning, trimming the monopole and getting your best response at 1420, then combining two of those should theoretically pretty much half the impedance. So if you have it tuned right, it'll be 50 ohms. If you combine both of those together, you should half the impedance. So, and the sawbird apparently is quite sensitive to impedance mismatch. So perhaps that's what you're seeing. You're actually, instead of maximizing your 50 ohm signal, you're now trying to get a 25 ohm signal into the input of the sawbird, which would really kind of not be too happy with.
But as I understand it, when you connect the two together, it works better, right?
Or I don't know if it's better, but it works the same as if you use one on their own.
Right. Okay, kind of weird.
Yeah. That's just my experience.
I'm thinking something's happening in GNU where those two files being combined are either subtracting each other or doing something strange. Like I said, GNU, it just seems to be like, unless you actually have written the software for it, it's hard to comprehend what those boxes are doing unless you're really intimate with the actual software. So it's not clear to me if that's not where the problem is actually at the processing end.
It's an interesting idea. There are delay blocks in GNU radio, so you could play with phasing at the digital level and see if you were just kind of unlucky with the original arrangement. If you
it might have
change the
something
phasing, could that then provide a peak?
Well, aren't you saying, Andrew, that you collect two separate files? You collect one file from one probe, and then you switch and collect a file from the second one.
No, it's simultaneous.
Well, they're both simultaneously being collected. Oh, okay. I misunderstood then. Sorry.
But if I'm right, Andrew, you're summing the FFT results.
Yeah.
So it's not a phasing issue then.
Yes, I hear your point. You're correct.
So I don't know. Yeah,
Strange.
Go do some more experiments and we'll investigate. You have got a good separation between the probe and the ground, haven't you? It's not shorting in any way to the side of the. Yeah, okay. Just checking. Yeah, I don't know.
Doesn't answer your problem, Andrew.
No. I've just, again, just while you've been talking, just been checking. Actually managed to get a bit of the videos up, but I still see signal on both. I can't directly tell how it compares to signal alone on one of them, so I think I may need to do the same experiment and actually do a screen record with just the one collecting data. So you're saying, Andrew, that even with the two monopoles in the waveguide, as long as you only collect data from one of them, you get an entirely normal signal.
Yeah.
if it is coming from the monopoles themselves affecting each other, how would they do that? So we talked about signal to wave ratio, but how would one, if it's going to have a normal signal, so clearly it can't be a physical effect of the monopole itself just being there inside the waveguide, because if you're going to collect it from one, then you get a normal signal. So how can collecting data through the second monopole actually affect the first? How would that occur?
Well, the only thing that I can think of is that you're using a common ground, and whether there's a ground issue between the Sawbirds when you put two on together, if you like. That's the only thing I can think of.
Yes, that common ground has a length, and so now we're worrying about phases.
All right, so you're saying that the ground on the two isn't quite the same as each other?
No, that can't be right. That can't be right. It should have no effect on each other. One experiment you might want to try, for example, is totally disconnect one of the monopoles while you're recording from the other, and then do a recording of that, and then try shorting out the second monopole. Just put like I don't know, if you have a VNA, you have those calibration plugs.
Oh yeah,
one of
yeah.
those is short.
Yep.
Short out one of the monopole you're not using. Short it out,
Mm-hmm.
and then see if recording from the first monopole is affected, whether that second monopole is shorted out or not. If you short it out, then that might alter now, because now that's a intrusion into the cavity from the ground, if you have that second monopole shorted, and so that might affect. So, but while it's open, that center monopole is if it's not connected to anything, it shouldn't be interacting through any kind of ground connection. So perhaps then maybe something like that short is happening when you're connecting two of them together. At least with one shorting to ground. So I'm not sure if that would make any difference or not, but it might be something you can try and see if it makes any difference whether that second monopole is shorted to ground or just left floating into the cavity. But they should be interacting with each other, not at 90 degrees. The phase angle at 90 degrees it's zero. So any interaction between the two of them shouldn't exist. I mean, they should cancel out. So yeah, it's hard to understand your results.
I know.
I shall try those. I'll do my best to try those two experiments and bring it to the next meeting. I think I've opened a can of worms here, but thank you, Andrew, for
very interesting.
as with everything else, looks like you're trailblazing ahead of the rest of us. So it's marvelous, actually. I just bumble along as always, but it's great fun. I got to say, having worked as a doctor for years, the main difference between this hobby and working as a doctor is that there was the problem that my patients didn't like to be killed, albeit accidentally. They expected me to get it right every time, whereas here I can just be a complete idiot with complete impunity, because it doesn't make any difference at all to anyone. And then people do things like this. They make you chair of a hydrogen line group. I think it's in direct proportion to your idiocy, actually. And now I'm being invited to write papers for astronomy now. I've even had an invite. I don't know if I can do it actually this year, but I've even had an invite to do a presentation at the British Astronomical Association Winchester weekend next year. Although it looks like I probably won't be able to make it, but we'll have to see. So life is weird. Life is weird. But is there anything else that anyone would like to talk about before we finish? Well, I, for one, think that's been an absolutely fantastic meeting. Sorry, who was that?
I said nothing from me.
Oh, nothing from you. I don't want anyone to feel that they're missing out. Do you know, we've just taken 2 hours and there's only 6 of us. How Rich gets through everybody on the SARA meetings, I've got no idea. Perhaps he just keeps them to time. Okay, when would you like the next meeting, guys?
You mentioned,
Yeah.
you mentioned earlier that the meteor meteor reception that perhaps you had some information on that. I don't know if you could break in a small time slot segment to also discuss the meteor scatter reception that I know you guys are doing. We don't have the French radar in the U.S. to have the signals bounce off meteors, so it's a little bit harder for us to do observations trying to utilize weak TV station signals.
But by the way, I did try last July to get the meteor scattering with the French radar. The problem is that I'm too close to the radar.
Oh yeah.
So when you look at the geometry, it goes over my head, over my antenna. So I was very frustrated.
That's a really good point. Heather, how does that work with the BAA beacon? Aren't we too close to it?
So our own beacon, it's we do actually receive it. You can see it itself, but the beacon is much lower power. The graphs one in France is kilowatts. Our one is 100 watts, and it's pointing vertically, so you get very little horizontal radiation for it.
All right. Okay, that makes sense.
But if people, as I said, if people vote for it, I could do you a little bit on it.
Okay.
10-minute talk on it.
Well, let's ask the group. Is everyone happy for Heather to give us perhaps anything up to 20 minutes talk on meteor observing next time?
Yeah, I can show you some screen. I did try to get some meteorite signal. So
Okay, I'll tell you what. We'll do a detour next meeting. I know we're the Hydrogen Line group, but we'll do a detour and have a special meteor observing session led by Heather, who'll give us a chat to start with. In that case, if we're going to make it a special session on that, Heather, we'll anything up to half an hour, whatever you want to take, is your choice. And then Michelle can give us a brief chat yourself, perhaps 10-15 minutes, whatever you fancy, Michelle, from your side in France. But we have discovered something. All you need to do is contact Graves and ask them to point the antennae directly upwards, and you'll be fine. It won't matter that you're too close to it, and turn the power down a bit.
Well, I think they are actually pointing upwards, but if you're that close, it doesn't matter with kilowatts, because I think the main it's actually a space detecting arrays with the actual objectivity of it.
That's the purpose of BRAP is to identify also, like you do with the NASA. NASA is doing it, but in France they do the same. They try to track all the objects, near objects.
Okay. Yeah, we used to have a similar system here in the U.S. It was called VASPER, or the space picket fence is what they called it. There were like 3 or 4 transmitters along the southern border of the U.S. that were pointing straight up with again kilowatt type, and I believe those operated around 220 megahertz, which I think it's a little bit higher. And I think Graves is it's around 150, something like that, megahertz. Okay, and the BAA system is operating on the 50 megahertz 6 meter band. Is that correct, Evan?
It's
Heather's the expert.
band, but yes,
Yeah, all right. So those are all different frequencies. But anyway, the U.S. system was fantastic. You could really do some really great meteor bounce off of that. But here, unfortunately, about 7 or 8 or 9 years ago, they shut it down. They decided it was not giving them the results for the money spent. But so anyway, that's kind of a shame. But that's what we used to use here in the U.S. before, and so now we have to rely on TV stations, which are just horrible with their sort of digital spread signal, which is like 5 megahertz wide, and looking at this little pilot signal is just really, really hard to do in my mind. But anyway, yeah, looking forward to that.
I'll be interested to talk about it because I did try to figure out the geometry. What I understand is the meteorite, they can get burned and they get ionized about 120 kilometers up in the sky. So when I look at my position, this graph, as I said, I think most of the signal go above. But I get some signal, identify some meteor, but it was not as I expected. So it will be interesting to talk.
Okay, so the next meeting, we're going to have a special meeting on meteor observing. Nothing to do with hydrogen online really, but meteor observing at the Questa Group, with a talk by Heather, and then followed by another short talk by Michelle on doing it in France. And then maybe Adrian might want to make some comments on America and trying to pick up on TV stations. I'm sure he'll have something to say about that. And anybody else would like to say anything about it too. Okay, before you go, should we set a date? Should we set a date for the next meeting?
Thank you, Andrew. It was great.
Oh, but for the next meeting, I mean, normally we're the first Monday. That would be the 3rd of November. How does that work for people?
Fine for me.
Oh, yeah.
Yeah.
3rd of November. Oh, I guess that's fine. Yeah.
Okay.
Well, do you think it's a problem for you? Do you think, Adrian?
I was actually thinking October now coming up. Never mind. I had a doctor's appointment that day on October the 3rd. So, but no, November's fine. Yeah.
So Heather and Michelle, they're fine on that day, are you?
Yeah.
Yeah.
Fine by me.
Yeah, and Ted, are you okay for that day? I assume I don't hear anything to the contrary. He's fine with that day.
Already on in my calendar.
Okay, brilliant. So the 3rd of November it is.
Okay.
Thank you.
All the best, guys.
Everybody.
And thank you very much for a really enjoyable evening.